Good day, folks. Lately, we've been discussing about a introduction of sets and the kind of sets and notations. But today, we are going to discuss about how to solve a subsets and Venn diagram. By the way, I am Sir Mark Anthony P. Halop, and I am a advisor from grade 7 Skoda, siyempre sa Mogchs. So, proceed na tayo. The question is how to solve for subsets. So, example number 1. Given the set of M has two elements, okay, which is X and Y. Write the complete list of subsets. The complete list of subsets are the empty set or null set, X, Y, and the X and Y. Therefore, we have 4 subsets of the given set M, which is empty set, set X, set Y, and the set of X and Y. So, yan na simple. Example number 2. Okay. Given we have a set of F which is nasa 3 ka-elements. So, write the complete list of subsets. Subsets ang ipangita. Note that set F has 3 elements gyapon. In symbol, n of F is equal to 3. First, we have the empty set. Next, we have 1, we have 2, we have 3, we have 1 and 2, we have 1 and 3, we have 2 and 3, and lastly, we have 1 and 2 and 3. Na pa ba? Wala na, no? So, therefore, there are 8 subsets for the given set of F na yung element is 1, 2, 3. Okay, when you notice, kumbaga, tanan part or tanan elements nga naa nga set, gibahin-bahin. Okay? So, kinsa tong pwede. So, as long as nara siya sulod sa elements. So, please take note. But, dili na ta magtinamban, no? Because we have formula. So, para mas dali ang pag-solve sa tong subsets, we have a formula which is C2n. The subset of a given set can be solved using the formula 2n, where n is the number of elements in a given set. Again, n, the number of elements in a given set. Let us proceed to the other example. So, again, the number of elements in a given set, mo nang si n na. So, example number 3. Number of elements, let's say 3. So, just substitute the value of n into 3. So, 2 to the power of 3. So, 2 times 2 times 2 is equal to 8. Another example. If the number of elements is 4, so, substitute lang, lisan si n kung 4. So, 2 times 2 times 2 times 2, 16. So, if number of elements is 5, so we have 2 to the power of 5. So, 5 ka 2. 2 times 2 times 2 times 2 times 2 times 2. That is equivalent to 32. So, that's it. Nga na lang ang pag-solve gamit ang formula ni subsets. Another example. Ay, wala na din. So, now let us proceed to how to solve for Venn diagram. Okay? Anyway, what is Venn diagram? A Venn diagram is a widely used diagram style that shows the logical relation between sets. No? It was popularized by John Venn in the 1880s. So, as you can see, we have 2 colors here, blue and red. Okay, when you notice, nailang colors ato nga, that is violet. If we're going to combine the 2 colors, makaproduce siya ng light na color, which is red. Same gyapon here sa tong topic. Now, with the help of Venn diagram, makaingon ta kung kinsa tong mga subsets ana nga numbers, ana nga elements, I mean. So, next slide. These are diagrams that make use of geometric shapes to show relationship between sets. So, mo na yung relations na representation, no? We have circle A, then si V dayon kay pentagon. Explanation niya is, all elements in A and B are contained in the universal set. So, what is universal set? So, na-discuss na ganina, no? Ni Sir Mark. Next, it is very useful in showing the relationship between sets. So, gamit daw kayo siya para makita nato unsay naa kang A, unsa naa kay V. Here sa tong presentation, we can say that sets A and B are disjoint sets. So, you already know what is disjoint sets, no? Disjoint sets is kanang wala sila na walay kapareha, walay common silang duha. So, muna siya ang lagway sa Venn diagram nga walay common. Murag ka mo sa imong char. So, anyway, next slide. I hope na nakasabot mo kay Venn diagram, no? So, next slide. How to say thank you. Okay, thank you. Kay nagtanaw gid mo sa akong slides. Thank you for watching this video. I hope you learn something from me. I hope na di ninyo malimtan ang among mga gipang discuss karon. And next topic, we have the introduction of union sets by Ma'am Lagulay. Thank you so much, guys.
Good day, my dear students. This is Teacher Roslyn from the Mathematics Department. Today, we will define and describe the union and intersection of sets. And we will use a Venn diagram to represent the union and intersection of sets. Before we proceed to our topic, let us see if we will still remember our previous lesson by answering this activity. Let's do it this way. Arrange the jumbled letters to get the correct answer. Write the answer in your paper. I will give 5 seconds in each number. The first one is done for you. It is a well-defined collection of each distinct objects. And the answer is set. Number 2, it is the set of all possible elements of any set. The answer is universal set. Number 3, a set with no elements. The answer is null set. Number 4, two sets that contain the same number of elements. The answer is qualitative set. Number 5. It is a diagram that makes use of geometric shapes to show relationships between sets. The answer is Venn diagram. Number 6. These are sets with a defined number of elements. The answer is finite. Number 7. This is a method describing a set by listing each element of the set inside the symbol. The answer is roster. Number 8. Two sets that contain the same elements. The answer is equal set. Number 9. These are sets having no element in common. The answer is disjoint set. And number 10, it is a method of describing a set in words. The answer is verbal set. If you get all correct answer, then let us proceed with our topic today. Observe the given figures below. We have figure 1 and figure 2. Notice in figure 1, the objects in box C are the objects from box A and B. If you combine the objects from the box A and B, the result is box C. But take note, in box C, there is no repetition of objects. On the other hand, figure 2 illustrates the box F is just a result if you get the common objects from the box D and E. In sets, combining the elements without repetition is called the union of sets, while getting the common elements is called intersection of sets. These are called the basic set operations. In arithmetic, we have 4 basic operations such as addition, subtraction, multiplication, and division of numbers. In sets, we have also the 4 basic set operation. In this lesson, we will discuss the first 2 operations, namely union and intersection of sets. The last 2 operations will be discussed in the next lesson. So we have the union of sets. The union of sets A and B, written the union of sets A and B. Take note of the symbol. It looks like U. It is the set of all the elements that are in A or in B or in both A and B. We can say that the union means all the elements. So we will combine all the elements that are in set A and set B. Example: find the union of set A has an elements of 2, 3, 4, and B has the elements of 3, 4, and 5. So, the union of set A and B is equal to 2, 3, 4, and 5. How are we going to show it using a Venn diagram? So, we will have set A and set B. Since the common element is 3 and 4, we will place it in the center where the circle is overlapping. And the elements in A that are not in B is 2. Then the elements in B that are not in A is 5. Next is the intersection of sets. The intersection of sets A and B, written the intersections of sets A and B. Take note with our symbol. It looks like an inverted U. This is the set containing the elements that are in both A and B. This means that we look for the elements that are found in A and in B. In the other words, there is a common element for the set A and B. Example number 1. Set A is equal to 2, 3, and 4, and set B has an elements of 3, 4, and 5. So the intersection of set A and set B are 3 and 4. So these are what we call common elements. We will show it using Venn diagram. So the elements that we'll put first are the common elements or the intersection. So the common elements is 3 and 4. The example number 1 shows adjoint sets. It means there are common elements. Another example number 2, sets A are 3, 1, 3, 5, and 7, and set B 2, 4, and 3. What are the common elements? There is none. It means that the intersection of A and B is null set. Let us show using a Venn diagram. Do you notice that the circle did not meet because it is a null set? Let us have more examples. Let us have number 3. The elements for x 2, 4, 6, 8, and 10, and 12. And for y, the elements 3, 6, 9, 12, and 15. For z, we have 1, 4, 7, 10, 13, and 16. We will find the union for the x and y. And for letter B, we'll find the intersection for the sets y and z. So for letter A, the first is you will list the given elements of sets x and y. Finally, get the union of the x and y. This means that combine all the elements. If an element is in the both sets, we list it only once. Another problem is to get the intersection for sets y and z. First, list the given elements of sets y and z. Finally, get the intersection of y and z. Note that the intersection is the common element. Since there is no common element, so the answer is a null or empty sets. So, this is all for today. I hope that you will learn with our lesson. Thank you for listening and God bless.
Hi, good day. Welcome to today's lesson. I am teacher Sophia Amper from Misamis Oriental General Comprehensive High School, your math buddy for today. I am here to help you with your logical reasoning and your critical thinking skills. For this lesson, you are expected to define and describe the different set operations, perform set operations, and represent the set operations using the Venn diagram. In the previous lesson, we defined what is union and intersection of sets. Another related concept to set is complement of a set. Complement of a set is a set of all elements in the universal set U that are not in set A. This is denoted by an apostrophe read as prime. Thus, the notation used for the complement of A is A prime. Now, let's have an example. The universal set contains the 26 English letters of the alphabet, and our set V are elements that contains the vowels. What is V prime? That's right. V prime are the consonant elements. Let's have another example. The given is the universal set V is the set of all natural numbers from 2 to 10. Set A is the set of all even numbers from 2 to 10. And set B is the set of all prime numbers from 2 to 10. Now, what are the elements of A prime? Did you answer A prime is equals to the element of 3, 5, 7, and 9? Excellent! Elements 3, 5, 7, and 9 are elements that are not found in our universal set. How about our B prime? Job! B prime is equals to the element of 4, 6, 8, 9, and 10. Thus, these are the elements found in our universal set that are not in B. To show it in our Venn diagram, look at your screen. As you notice, the shaded region on our Venn diagram for A prime are the elements that are not found in A. And so with our B prime, the shaded region are elements that are not found in our set B. We are doing a very good job, and we are halfway to our lesson. Let's proceed to difference of a set. Difference of a set is the set containing elements of set A but not found in B. Let's have our first example. Set A are the elements 3, 4, 5, and 6, while set B are the elements 2, 4, 6, and 8. Find A minus B and B minus A. For our A minus B, can you guess the answer? That's right. A minus B is equals to the elements 3 and 5. These elements are not found in our set B. How about B minus A? Did you answer 2 and 8? That's correct. You're doing a good job. How about we show it on our Venn diagram? Time is up. Look at your screen for answers A minus B and B minus A. It's your turn now. Given, universal set are the elements 1, 2, 3, 4, and 5. Set A are the elements 1, 3, and 5. Set B are the elements 3, 4, and 5. And set C are the elements 2 and 4. Find A prime, B prime. A C prime and B minus C prime. For A prime B prime, that is elements 2, 4, and 1, 2. Thus, we have the final answer 1, 2, and 4. Start answering for letter B, A, C prime. For AC prime, that are elements 1, 2, 3, 4, and 5. Thus, we have a null set or an empty set. For the last item, answer letter C, B minus C prime. C prime, we have elements 3, 4, 5 minus 1, 3, and 5. Thus, we have 4. It's a wrap for today's episode. See you again next time. This is Teacher Sophie. Goodbye and keep safe, everyone.
Welcome, grade 7 students. Today we will have another lesson for our math week. By the way, I am Teacher Lorraine and please listen carefully. Okay, the objectives for this lesson, the students will be able to describe the definition of Venn diagram, draw Venn diagram, and solve problems using Venn diagram and the start inside-out technique. So first, let us define what is a Venn diagram. According to John Venn, the diagram shows the relationships between sets, their similarities, and differences. It was in fact named after him. Okay, so a Venn diagram shows you the relationship between sets. It could be more than two sets. Okay, so it will show you the similarities and the differences between the sets. Okay, next, study the illustrations below. So as you can see, there are three columns. So the first column is the set notation, second column is the Venn diagram, and the third column is the examples. So first is the set A. When you say set A, elements belong to set A. In the diagram, the only shaded part is the set A. It means all the elements belong to set A. As you can see in the example, the letters Y and OP belong to set A. Okay, for the set B. For the set B, the elements belong to set B. So as you can see in the example, the letters P, O, T belong to set B. Okay, next is the intersection. The intersection and the elements are common to set A and set B. Okay, the key point for the intersection is common between the two sets. Okay, in the example, so there are letters N, Y, P, O, and T. So the letters N, Y, P, O belongs to set A. And for the letters P, O, T belong to set B. But the common letters there between the two sets is the letters P and O. Okay? Next, the union. Okay? The elements which belong to set A or set B or to both sets. Okay? In the Venn diagram, both sets are shaded. It means all elements are united or in the set A or the set B. For the examples, the elements in set A is Y and OP, and the elements in B is OPT. So there are elements both set A and set B. Okay, next is the complement of A. In the figure, it is all shaded except for the set A. Because complement of A is the elements of U that do not belong to A. So we say A is the universal. So all elements but do not belong to A. So in the example, so there are elements outside the set, that is the letter I, and there's an element in set B that is letter T. But it does not belong to set A. So therefore, it's not shaded. Okay. For the complement B, okay, it is all shaded except for the set B. So it means the elements of the U that do not belong to B. So in the example, so there are elements in set A and the outside of the set. But there are no elements of set B because those elements belong to set A and outside of the set. Okay. Next is the difference of A and B. Okay. So the elements which belong to set A but do not belong to set B. Okay, so in the example, the only elements there are belong to set A. That is the letters N and Y. You do not include the intersection of the two sets because if you include that, element that belongs to the intersection will be included the set B. So if you are going to find the difference of a set A and a set B, so that element should be really in the set A or the set B. Okay? Next is the real life application of the Venn diagram. So for this example, a class of 25 students were surveyed and asked if they have a brother or a sister. 8 students said they have only a brother. 6 students said they have only a sister. Another 6 said they have both a brother and a sister. And 5 said they don't have a brother or a sister. Okay, so how are we going to transform this problem into a Venn diagram? Okay, so let's make a figure of two sets because it was asked to if a student is have a brother or a sister. Okay, that's why we only have two sets. Okay, in the first figure, okay, the first set there, it belongs to the brother, so the brother only, and the second set is the sister. Okay, and the intersection is that they have both brother and sister. Okay, so this is the first figure. If you are going to transform this into number, okay, so in the second figure, so the students who said that they only have brother is 8, right? So you can see 8 students said they have only a brother. Okay, first, let's that. Okay, so 8 students said they have only a brother. Okay, next. And there are 6 students said they have only a sister. Okay, that's why we put 6 to this set. And the another 6 there is they have both brother and a sister. That's why we put another 6 here. And next is and 5 of them said they don't have a brother or a sister. It means they're only child. That's why the 5 is outside of the set because these 5 don't have brother or a sister. Okay, so that's how are you going to present or transform a problem into a Venn diagram. Okay, another example. A group of students were interviewed on what colors they like. Below are their responses. Okay, so we have 3 colors, the yellow, blue, and red. So how are we going to solve that? Okay, these are the questions. Letter A, how many students like blue color? Okay, so the blue color, so the numbers that are belong to the set blue, you just simply count that. So 9 plus 7, that is 16, plus 5, that is 21, plus 4, that is 25. So there are 25 students who like blue color. Okay, letter B. How many students like yellow and red? Okay. How many students who like yellow and red? Okay. So, these students both like yellow and red. So, the intersections of yellow and red, you just simply count that. So, 5 plus 3, that is 8. So, these 8 students who like both yellow and red. Okay, next. How many students like yellow or blue? Okay, so how are we going to solve that? Okay, simply you just count all the numbers belong to yellow or blue. Okay, just simply count all the numbers belong to set yellow and set blue. Okay, 9 plus 4. 13 plus 7, 21 plus 5, that is 26, plus 3, 29, and plus 11, 29 plus 11 is, wait, 9 plus 4 is 13, plus 7, okay, plus 7, that is 20, plus 5, that is 25, plus 8, 28, then plus 11 is 39. Okay, so there are 39 students who like yellow or blue. Okay, next. How many students like yellow only? Okay, when you say yellow only, so those elements that do not belong to the intersection of the other sets. So the students who like yellow only is 11. Okay. Next, how many students like yellow, blue, and red? So how many students who like all the 3 colors? Okay, so the intersection of the 3 colors is this only. So there are 5 students who like all the 3 colors. Okay, next. How many students like blue or red but not yellow? Okay. So we will not include the elements that belong to yellow. The elements that belong to the blue and red are only the 9, 4, and 17. So we're just going to add those numbers. So 9 plus 4, that is 13, plus 17, that is 30. So there are 30 students who like blue or red but not yellow. Okay, next. How many students like neither yellow, blue, nor red? So how many students who don't like those three colors? So if we're going to look for the figure, this number two who outside of the set, so those students that don't like those three colors. So your answer there is 2. Okay? Simple, right? Okay. Okay, the next lesson is the start inside out technique. Okay, so for this lesson, it will show you how to solve some complicated questions. Like for this problem, okay, out of 50 students, 23 joined mathematics club and 32 joined English club. So if 8 of the students joined in both mathematics and English club, how many have joined the English club only? How about in mathematics club only? And how many are neither in mathematics nor in English club? Right? So there are 3 questions. So it's kind of bit complicated. So if that kind of questions in a problem, so you will use the start inside out technique. Okay, so there are procedures and how are we going to do that? Okay, first, arrange the given data this way. Okay, that is data. So there are out of 50 students, 23 joined mathematics club, 32 joined English club, and 8 joined in both math and English club. Okay, so the questions again, letter A, how many have joined the English club only? Letter B is how about in mathematics club only? And letter C is how many are neither in math nor in English club? Okay. Okay, number 2, make a Venn diagram. So we just only have 2 sets because they're only given 2 clubs, the math club and the English club. Okay. So draw 2 overlapping circles representing 2 sets, the math club and the English club inside the U. Okay, number 3. Okay, 8 joined both math and English club. So we are going to put 8 at center where the 2 sets overlap. Okay, so let's put 8 here because they both joined the math and the English club. Okay, number 4. So there are 32 joined the English club. Okay, so we will not put the 32 immediately to the English club because these eight students joined both of the clubs. Okay, so how are we going to solve for that? First is subtract 8 from the 32 who joined the English club. From means you need to write 32 first before 8. That is 32 minus 8 is equal to 24. So put 24 in English club only. So this completes the 32 students who joined the English club. Okay? Next, 23 joined the mathematics club. Okay? So subtract 8 from 23. So 23 minus 8, that is 15. So put 15 in math club only, and this completes the 23 students who joined the mathematics club. Okay? And number 6, out of 50 students, so how many students who did not join both of the clubs? Okay, so first is we're going to add all the elements of the sets. Okay, 15 plus 8 plus 24, so that is 47. So since the total is 47 and not equal to 50 because there are 50 students, so subtract 47 from 50. So 50 minus 47, that is 3. So put 3 outside the 2 sets but inside the U. This completes the 50 students. Okay, easy, right? Okay, another example. Okay, wait. We will answer the questions that were asked in the problem. Okay, letter A. So how many have joined the English club only? So when you say only, those students who have joined the English club only. Okay, so there are 24 students. And for letter B is, how about in mathematics club only? So there are 15. And how many are neither in math nor in English club? So that is 3. Okay? Another example. What if the problem involves 3 sets na? So the first example, that is 2 sets. So this time, 3 sets. Okay. Problem 2. A group of 50 students went to a tour in Palawan province. Out of 50 students, 24 joined the trip to Coron, 18 went to Tubataha Reef, 20 visited El Nido, and 12 made a trip to Coron and Tubataha Reef. And 15 saw Tubataha Reef and El Nido, and 11 made trip to Coron and El Nido, and 10 saw the 3 tourist spots. Okay. It's really complicated. So the questions there, how many students went to Coron only, and how many students went to Bataha Reef only, and how many joined the El Nido trip only? And the last question is, how many did not go to any of the tourist spots? Okay, so we have there three tourist spots, the Coron, to Bataha Reef, and the El Nido. That's why we will use 3 sets. Okay, so again, first is we are going to arrange the given data. So the 50 students went tour in Palawan province, 24 joined a trip to Coron, 18 students went to Bataha Reef, 20 visited El Nido, 12 made a trip to Coron and to Bataha Reef, and 15 saw to Bataha Reef and El Nido, and 11 made a trip to Coron El Nido, and 10 saw the 3 tourist spots. Okay, so first make a Venn diagram, of course. So there are 3 sets, man. Okay, so let's see. Represents Coron, E represents El Nido, and T represents the Tubataha Reef. Okay, so according to the data, there are 10 students who saw the 3 tourist spots. Okay, so put 10 at the center where set C, E, and T overlaps. Okay, so then ang 10. Okay. Next, number 3. 11 made a trip to Coron and El Nido. Okay, so both Coron and El Nido. So how are we going to solve that? So subtract 10 from 11. So 11 minus 10, so 1. So put 1 in set C and E only. This completes the 11 students. Okay, number 4. 15 so to Bataha Reef and El Nido. Okay, subtract 10 from 15. So 15 minus 10 is equal to 5. So put 5 in a set T and E only. This completes the 15 students. Okay. Next, number 5. 12 made a trip to Coron and to Bataha Reef. So subtract 10 from 12. So 12 minus 10, that is 2. So put 2 in set C and T only. This completes the 12 students. Number 6, 20 visited El Nido. Add all the given elements of set E. So that is 10 plus 5 plus 1, so 16. So subtract the total from 20 who visited the El Nido minus the 16. So that is 4. So put 4 in set E only. This completes the 20 students. Okay, number 7. 18 went to Tubataha Reef. Okay, so add all the given elements of set T. So 10 plus 5 plus 2, so that is 17. So subtract the total from 18 to 17. So 18 minus 17, that is 1. So put 1 in set T only. This completes the 18 students. And number 8 is 24 joined the trip to Coron. Add all the given elements of set C. 10 plus 2 plus 1 is equal to 13. Subtract the total from 24. So 24 minus 13, that is 11. So put 11 in set C only. This completes the 24 students. And the number 9 is 50 students went to a tour in a Palawan province. Yes. Okay. Add all the elements. So 11 plus 1 plus 10 plus 2 plus 4 plus 5 plus 1. So 34. Okay. So add all the elements inside the three sets. Okay, and you subtract that from the 50 students who went tour in Palawan province. So 50 minus 34, that is 16. So put 16 inside the U outside the sets or the circles. Okay, so those 16 are actually the students who did not went to a tour in Palawan province. Okay, for the questions, here are the answers. So how many students went to Coron only? Okay, went to Coron only, that is 11. If it is Coron only. And how many students went to Bataha Reef only? So that is 1. And how many joined the El Nido trip only? So that is 4. And how many did not go to any of the tourist spots? So that is 16. Okay, that's all, and thank you for listening. Your teacher will teach you more or explain to you further about this lesson. Thank you.
Welcome to Grade 8 Science. I'm Teacher Rubes. So before we start, can you arrange these scrambled words? Yes, this is potential energy or known as stored energy. To define potential energy, it is an energy or known as stored energy that depends upon the relative position of various parts of a system. For example, a spring has more potential energy when it is compressed or stretched. A steel ball has more potential energy raised above the ground than it has after falling to earth. So we have here some examples of potential energy. A raised weight, water that is behind a dam, a car that is parked at the top of a hill, a yo-yo before it is released, river water at the top of a waterfall, a book on a table before it falls, a child at the top of a slide, and then ripe fruit before it falls. Now, those are examples of potential energy. Now, to understand further, I have here some illustration about potential energy. Let's take a look at this. This is the massive ball of a demolition machine, and the stretch bow possesses stored energy. We have another example of potential energy, as you can see in the picture. Another example, this one is a potential energy. This one also applies potential energy. Okay, as you can see here in the picture. In addition to, I have here some illustration for the examples I have mentioned a while ago. So from that, stretching a rubber band, it stores energy. Another, water at the top of a waterfall. It stores energy also. And then you can see in the picture, yo-yo. Yo-yo inhaled in your hand. It stores energy because of position. And we also have here the illustration of drawing a bow. And it stores energy also because of position. Furthermore, potential energy, energy that is stored and being held, waiting to be used, is like potential energy. Some examples here are a car parked in a parking lot, a child at the top of a slide, a ball sitting on a table, and someone pulling an arrow back on a bow. I have here a question. Which of the following is the best example of potential energy? A. Number one, fire. Number two, match. Number three, balloon. Number four, thunder. The correct answer is yes, it's a match. Do humans have potential energy? Take note. Your body uses chemical potential energy stored internally to do work. And that process also generates thermal energy, which you release as exhaust heat. What is potential energy? Potential energy of an object is found in its position, not its motion, and it is the energy of position. From this illustration, you have the formula PE are known as potential energy, mass times acceleration due to gravity and your height. And all you have to do there is just multiply mgh. So when you look at like this, you just simply multiply the number substituted in that particular variable. Please be reminded that in potential energy, as mass decreases, potential energy decreases. Now, to summarize, potential energy is the energy that is stored in an object due to its position relative to some zero position. An object possesses gravitational potential energy if it is positioned at a height above or below the zero height. Thank you so much for watching. I hope you have learned a lot today and see you in my next video. Good morning. Welcome to Graded Science. This is Teacher Rubes. How are you today? Wow, good to hear that. All of you are great. So, welcome to my class. Before we start, can you take a look at this picture? Okay, so later on we will talk about it. And today we will discuss about kinetic energy. It is the energy of motion. When an work is done on an object and it accelerates, it increases the kinetic energy of an object. Kinetic energy is a form of energy that an object or a particle has by reason of its motion. Well, kinetic energy is the energy of motion observable as the movement of an object particle or set of particles. And take note, any object in motion is using kinetic energy. I have here some examples to understand further what is kinetic energy. For example, a person walking, a thrown baseball, a cramp falling from a table, moving car, bullet from a gun, walking and running, cycling, roller coasters, cricket ball, and skateboarding. So those are examples of kinetic energy. Then we have kinetic energy can be defined as the energy which is present in every moving object. And we can simply say that kinetic energy is the energy because of motion. So we have here the formula of kinetic energy. 1/2 mass times velocity squared. So you're gonna square mass and then you're gonna get 1/2 mass times velocity squared. You square the velocity.
It says that m is the mass of the object that is in motion and v is the velocity. Therefore, we can say that kinetic energy is directly proportional to the mass and square of the speed of the object in motion. And by keeping this formula, let us take a few examples where we observe kinetic energy in our day to day life. Okay, so we have here, oh, what can you see in the picture? Okay, one of the examples of kinetic energy is a hydropower plant. A hydropower plant, as you can see there, are places where generation of electricity takes place with the help of water. And with the moving water possessing some kinetic energy, it hits the turbines present in the dam. And this kinetic energy of the water gets converted into mechanical energy. This mechanical energy moves the turbines and then ultimately it leads to the production of electrical energy. Next example is the windmills. Are you familiar with that? Windmills form one of the good examples of applications of kinetic energy. In a windmill, when the wind, air in motion, hits the blades, it causes the rotation, which ultimately leads to the generation of electricity. Here, the moving air has kinetic energy that causes the rotation of blades, and therefore, in this example too, the kinetic energy is then converted to mechanical energy. The next one is this is very popular to us. We have moving cars that possess some amount of kinetic energy. This is because they have some mass and velocity. Then wow, this one. Bullet from a gun. A bullet fired from a gun has very high kinetic energy, and so it can easily penetrate any object. Why? This is because of a large amount of velocity possessed by the bullet. Although the mass of the bullet is less, its high speed renders double the amount of kinetic energy. Another example, we have, oh, among you here, ride an airplane, flying airplane. A flying airplane has a very high amount of kinetic energy. Why? Why do you say so? Because not only does it has a large mass, but it also has a very high velocity. And both these figures resulted in heightened kinetic energy of the airplane when it is flying. And this is the reason why airplanes are able to fly high. Okay, moving on, we have walking and running. How about you, class? Did you walk? Did you run? When, when walking or running, we possess some amount of kinetic energy. Do you agree? Yes, this is why we feel comparatively warm while running or after walking some distance. Sweat is the result of the heat produced by our body due to running. While walking or running, there is a conversion of chemical energy into kinetic energy. Then we have, oh, I know you like it, cycling. Okay, cycling. The moving bicycles possess kinetic energy. The mechanism behind it is that when we start pedaling, we are converting our body's energy into the mechanical form, which is initially the potential energy and is converted into kinetic energy due to the motion of the wheels, as you can see in the picture. And more the velocity, more will be the kinetic energy. Okay, next example is wow. Roller coasters are fun to ride, isn't it? But ever given a thought about your wagon during a free fall? Well, when the wagon in the picture of a roller coaster is at the top, it has zero kinetic energy because the wagon is at rest. But when it is allowed to do a free fall, with a gradual increase in the speed of the wagon, then a gradual increase in the kinetic energy also takes place. And if a number of people are sitting in the wagon, it will increase the mass and hence the kinetic energy, provided that the speed remains constant. We have another example, dropping a glass on floor. What happens when we accidentally drop a glass on the floor? Initially, at the highest point, it possesses potential energy only. But as the gravity works and the speed is accelerated, the mass of the glass and velocity become responsible for the gradual increase in the kinetic energy. And at the lowest point, when the glass is about to hit the ground, the kinetic energy becomes maximum while the potential energy becomes minimum or negligible. Finally, when the glass hits the ground and breaks, the kinetic energy is released. All right. And we have here the last example. Are you familiar with that? Okay. So we have, what is that? Meteor shower. Although this example does not form a day-to-day example of kinetic energy, still it is very interesting. Why? Because it takes place in the solar system. You might be aware of the fact that meteoroids are scattered in our solar system. And whenever any meteoroid comes close enough to the Earth's atmosphere, it gets attracted by the gravity. Do you agree? As a result, it starts falling freely from the sky at a high speed. At that time, the kinetic energy of the meteorite is quite high because of its enormous size and weight. And when it hits the surface of the Earth with such a large amount of kinetic energy, explosions occur. And this is the reason for the presence of impact craters on Earth's surface. So those are examples of kinetic energy. Thank you so much for watching. I hope you have learned a lot today. See you in my next video.
Magandang araw sa inyong lahat. Ako nga pala, si Ginoong Chester J. O. Iduria, guro sa Filipino 10 mula sa Misamis Oriental General Comprehensive High School. Bago natin simulan ang talakayan sa araw na ito, manalangin muna tayo. Sa ngalan ng Ama, ng Anak, at ng Espiritu Santo. Amen.
Panginoon, maraming salamat po muli sa isang umaga na binibigay mo sa amin ngayon. Patnubayan niyo po sana kami at ilayo sa anumang kapahamakan. Maraming salamat po muli. Amen.
Pagkatapos ng aralin, ito ang mga kasanayan na dapat malinang ng bawat mag-aaral. Uulitin ko, magandang araw sa inyong lahat. Napag-alaman na natin ang iba't ibang akdang pampanitikan ng Mediterranean. Nakilala rin natin ang iba't ibang Diyos at Diyosa ng Greece. Ngayon, magpapakita ko ng 3 larawan. Kikilalanin ninyo kung sino ang nasa larawan. Unang larawan. Sino siya? Tama! Siya ay si Mercury, ang mensahero ng mga Diyos at Diyosa. Pangalawa. Tama! Siya ay si Venus, ang Diyosa ng pag-ibig at kagandahan. At ang pangatlo, sino siya? Napakagaling! Siya ay si Jupiter, ang Diyos ng mga Diyos sa mitolohiya ng Greece. Ano ang unang salitang pumapasok sa isipan ninyo kapag nakikita ninyo ang larawang ito? Valentine's Day, pwede. Magkasintahan, pag-ibig, pwede. Napakagaling! Cupid. Ang nasa larawang yan ay si Cupid. Si Cupid ay mayroong malaking kinalaman sa ating tatalakayin sa araw na ito. May 5 pangungusap akong ipapakita sa inyo. Bigyang pansin ang mga salitang may salungguhit at ibigay ninyo ang kahulugan ng salita. Unang pangungusap. Pangimbulo, ibig sabihin ay tama, pagkainggit. Pangalawang pangungusap. Tatalima, na ang ibig sabihin ay napakagaling, susunod. At ang pangatlong pangungusap ay immortal, nang ibig sabihin tumpak, walang kamatayan. Ika-4 na pangungusap, sumidhi, nang ibig sabihin ay napakagaling, tumindi o lumakas. At ang panglima, nagambala, nang ibig sabihin ay tama, na disturbo. At ngayon, manunood tayo ng isang video clip. Ang video na inyong matutunghayan ay pinamagatang Cupid at Psyche.
Naranasan mo na bang magmahal? At madalas kapag nababaliw ka na sa pag-ibig, ay sinasabi ng iba na para ka na ni Cupido. Alam kong kilalang kilala nyo kung sino ang tinutukoy ko. Madalas, ang karakter na ito ay bida tuwing sasapit ang Valentine's Day. Palagi siyang design sa mga walls, decoration sa mga post, mga cards na para kay GF or BF at kay mahal. Madalas pa nga noong elementary pinagdodrawing tayo ng puso o kaya naman ang hugis niya sa kulay pulang papel at gugupitin o kaya kukulayan ito para i-design sa room natin. At yan ay talagang madalas tuwing February 14. Pero alam mo ba na si Cupido ay napana niya ang sarili niya mismo? At naging dahilan upang umibig siya ng husto. Sa video ito ay pag-uusapan natin ang tungkol kay Cupido at sa babaeng tinutukoy ko kanina na nagngangalang Psyche. At gusto ko sabihin sa iyo na ang kwentong ito ay nanggaling sa Greek mythology. Siguro may idea ka na kung ano ang Greek mythology. Dahil madami na ding mga content creator ang gumagawa ng mga video tungkol sa mga ganito. Pero bago ang lahat, kung gusto mo at interesado ka sa mga ganitong kwento, ay siguraduhin mo nang napindot yung subscription button at notification bell para naman kapag nag-upload ako ay unang-una ka sa mga makakapanood nito. So, simulan na natin. Ako si Maria at ito ang aking kwento. Si Cupido ay anak ni Aphrodite o kilala rin sa tawag na Venus sa asawa niya si Ares. Siya ang diyosa ng pag-ibig at kagandahan kung kaya natural lang kay Cupido na maging Diyos siya ng pag-ibig at pagnanasa. May isang mahalagang alamat na patungkol kay Cupido at ito ay ang tungkol sa kanila ni Psyche. Si Psyche ay isang prinsesa. Hindi lang prinsesa, kundi napakagandang prinsesa na hinahangaan at sinasamba ng maraming kalalakihan. Ngunit sa kabila nito ay napakalungkot niya dahil kahit na marami ang humahanga sa kanya, ay wala namang gustong ibigin siya. Meron pang ang dalawang kapatid itong si Psyche na hindi naman kagandahan pero nakapag-asawa na ng mga hari at masaya nang naninirahan sa kalayuan. Samantala dahil sa kagandahan niya ay nakalimutan na ng mga tao na sambahin si Venus na siyang pinagmula ng galit nito sa kanya. At dahil dito, naisipan ni Venus na porosahan itong si Psyche. Hindi siya makakapayag na matalo siya na isang mortal lang. Kung kaya nabuo ang kanyang plano na paibigin ito sa isang halimaw. At ito ay iniutos niya sa anak niyang si Cupido. Mabilis namang sumunod si Cupido sa inuutos ng kanyang ina. Kung kaya't hinanap niya si Psyche. Ngunit nung makita niya ito ay nabigla siya sa taglay nitong kagandahan. Kung kaya't ang pana na para kay Psyche ay tumama sa sarili niya. Samantalang lubos na nag-alala ang amang hari ni Psyche. Nababahala siya na ang kanyang bunso at paboritong anak ay hindi na makapag-aasawa kahit kailan. Kung kaya't ito ay pumunta kay Apollo at dito ay humingi ng payo. Walang nakakaalam na naunahan na pala sila ni Cupido na pumunta sa orakulo. Nagmakaawa ito kay Apollo na gumawa ng paraan para maging asawa niya si Psyche. Ang sabi naman ni Apollo sa amang hari ni Psyche ay makakapag-asawa ito. Ngunit sa isang nakakatakot na halimaw, dinala nila si Psyche sa ituktok ng bundok upang sunduin na kanyang mapapangasawa. Iniwan nila ito doon na nag-iisa. Maya-maya pa ay dumating na si Zephyr, ang hangin ng kanluran, at dinala siya sa isang palasyo na ubod ng ganda. Ito ay gawa sa haliging pilak at ginto, at ang sahig naman nito ay puro hiyas. Ngunit lahat ng nilalang sa palasyong iyon ay hindi niya nakikita. Mayroong nagsisilbi para sa kanya pero puro boses lamang ang naririnig niya. Gayon din ang kanyang asawa ay hindi niya rin nakikita. Panatag na si Psyche na tumira sa palasyong iyon. Nang isang araw ay dinalaw siya ng kanyang mga kapatid na sobrang nainggit sa mga pangyayaring naganap kay Psyche. Sa isip nila, mga hari ng asawa nila pero hindi ganun kaganda ang kanilang palasyo. Kung kaya't sinulsulan nila si Psyche ng sinulsulan. At ang sabi pa nila na kung hindi pa nakikita ni Psyche ang kanyang asawa, ay matagal na nilang alam na isa itong halimaw. Sinabi nila kay Psyche na dapat unahan na niya ito bago pa siya mapatay. At sa gabing tulog na ay saksakin niya ito ng punyal at kapag namatay na ito, itutulungan siya ng dalawa na makatakas. Noong gabing ding yun ay daladala niya ang lampara at ang punyal. Ngunit nang mailawan ang mukha ni Cupido ng liwanag na nanggaling sa lampara, ay bumungad sa kanya ang pagkaganda-gandang lalaki nito. Ngunit natuluan pala ng kumukulong langis na mula sa lampara ang balikat ni Cupido na naging sanhi ng pagkagising nito. Agad itong umalis papalayo. Sinundan ni Psyche ang kanyang asawa. Pero nang lumabas siya ay narinig na lang niya na sinabi nito na kung sino talaga ito at uminikang hindi mabubuhay ang pag-ibig kung walang tiwala at ito nga ay tuluyan ang nawala. Napaisip si Psyche, si Cupido ang kanyang asawa at napagtanto niya ang kataksil kanyang nagawa. Nabuo ang plano kay Psyche. Hahanapin niya si Cupido at kahit anong pagsubok ay susuungin niya umibig lang muli ito sa kanya. Si Cupido naman ay umuwi sa kanila upang magpagaling. Isinalaysay niya sa kanyang ina ang nangyari. Galit na galit si Venus at lalong tumindi ang pagsiselos niya kay Psyche. Gustong ipakita ni Venus kay Psyche kung paano magalit ang isang diyosa. lalo na sa katulad niyang mortal. Naisip ni Psyche na baka umuwi si Cupido sa ina nitong Diyosa, kaya napagplanuhan niyang pumunta sa kaharian ni Venus. Nang makita ni Venus si Psyche sa kanyang palasyo, ay humalakhak ito at inisulto siya. Sinabi pa nito kung hinahanap nito ang dati nitong asawa, ay siguradong wala na itong pakialam sa kanya. At sinabi ni Venus kay Psyche na kung gusto niyang umibig muli sa kanya ang dating asawa, ay kailangan mapagtagumpayan niya ang 4 na pagsubok. Ibinuhos ni Venus sa harap niya ang isang malaking lalagyan bilang unang pagsubok. Ito ay punong-puno ng pinaghalo-halong iba't ibang uri ng maliliit na buto at sinabi sa kanyang dapat mapagsama-sama niya ang magkakapareho. Sa tulong naman ng mga langgam ay mabilis niyang natapos ang pagsubok. Sumunod naman ay ang pagkuha niya ng gintong balahibo mula sa mababangis at mapanganib na tupa na nakatira sa tabing ilog. Naisip ni Psyche na tumalon na lang doon upang matapos na ang kanyang paghihirap at nang may marinig siyang isang boses na bakit siya magpapakamatay. Pwede naman yung kuhanin yung mga nalagas at sumabit ng balahibo ng mga tupa mula sa mga halaman. Sa ikalawang pagkakataon ay nagtagumpay na naman itong si Psyche o kaya binigyan siya muli ng mas mahirap na pagsubok. Binigyan ni Venus si Psyche ng prasko at tinuro ang itim na tubig ng talon na nasa malayong lugar. Kailangan niyang punuin ito ng itim na tubig. Sa pagtungo ni Psyche sa ilog ng Styx ay nalaman niyang malalim ang bangin at mabato ito. Tanging mga nakalilipad na nilalang lamang ang maaaring makapag-igib ng tubig mula dito. Ngunit muli, sa hindi inaasahang pagkakataon, ay may nilalang na naman na tumulong sa kanya. Isang agila ang dumagit sa dalang niyang prasko at pagbalik nito ay puno na nga ito ng maitim na tubig. Hindi pa rin tumigil si Venus sa pagpapahirap kay Psyche. Sa pagkakataong ito ay binigyan sila ng isang kahon at inuutos naman itong kumuha ng kagandahan kay Proserpine sa ilalim ng lupa. At agad naman itong sinunod ni Psyche. Muli, isang tore ang tumulong sa kanya upang marating ang kaharian ni Hades. Detalyado nitong tinuro ang mga hakbang kung paano makakarating doon. Na una ay kailangan niyang pumasok sa isang butas na lagusan patungo sa ilalim ng lupa sa tabi ng ilog ng kamatayan. Kailangan niya sumakay sa isang bangkang babayaran niya ng pera at ito ay ang bangkerong si Charon. Kapag nakatawid na siya, ay may makikita siyang kalsada papunta sa palasyo. Pagdating naman sa palasyo ay may asang 3 ang ulo. Ngunit kapag binigyan niya ito ng cake ay magiging maamon na ito at papapasukin na siya sa palasyo. Lahat ng sinabi ng tore ay talaga namang nagawa ni Psyche. Kabalik siya kaagad, higit pa sa inaasahan. Ibinigay din ni Proserpine ang kahilingan ni Venus. Subalit, sa pagkakataong ito ay nasubok ang kurupukan ni Psyche. Natukso siyang buksan ng kahon sa paghahangad niyang mas lalo pang gumanda sapagkat naisip niya na iibigay siyang muli ni Cupido kung madadagdagan pa ang kanyang kagandahan. Pero nang buksan niya ito, ay wala naman itong laman. Kundi naramdaman niya ang matinding panghihina at agad siyang nakatulog. Sa mga oras naman na ito ay madilim na si Cupido at gustong-gusto na niyang makita si Psyche. Pero ikinulong siya ng kanyang ina. Subalit, sino ba ang makakahadlang sa isang taong umiibig? O kaya umanap ng paraan si Cupido upang makatakas at nakita niya ang bintana nakabukas. Doon siya dumaan. Agad niyang hinanap si Psyche na natagpuan naman niya malapit sa palasyo. Ninisin niya agad ito sa pamamagitan ng bahagyang pagtusok ng busog dito. Isingil niya ang gayuma sa kahon at nang magising na si Psyche ay pinagalitan niya ito. Dahil sa pagiging mausisa nito ay muli na naman itong napahamak. Sinabi ni Cupido na pumunta na si Psyche sa kanyang ina at ibigay na dito ang kahon at dito na rin matatapos ang pagpapahirap ni Venus sa kanya. Masaya namang pumunta si Psyche sa palasyo ni Venus at si Cupido naman ay lumipad papunta sa kaharian ni Jupiter, ang Diyos ng mga Diyos at Diyos ng mga tao. Hiniling ni Cupido na tiyakin na hindi na sila gagambalain pang muli ni Venus. Pumayag si Jupiter at nagpatawag ito ng pagpupulong sa mga Diyos at Diyosa. Kasama sa ipinatawag si Venus. Sinabi ni Jupiter sa lahat na formal na ikinasal sina Cupido at Psyche at wala nang sino man ang pwedeng gumambala sa kanila maging sa Venus. Dinala ni Mercury si Psyche sa kaharian ng mga Diyos at dito inabot ni Jupiter kay Psyche ang ambrosia, ang pagkain ng mga Diyos upang maging immortal. Sa kabilang banda ay natahimik na din si Venus dahil naging Diyosa na si Psyche sapagkat wala na siyang kaagos sa pagsamba ng mga tao kung maninirahan ito sa kaharian ng mga Diyos. Ang pag-ibig ni Cupido at kaluluwa ni Psyche ay nagkatagpo sa likod ng mapapait na pagsubok, ngunit ang kanilang pagsasama ay hindi na mabubuwag kailanman.
Sa puntong ito, may 3 kulay kayong pagpipilian. Ang bawat kulay na ito ay mayroong nakaatas na gawain. Ang 3 kulay ay ang kulay pula, luntian o berde, at kulay asul. May napili na ba kayo? Kung sino sa inyo ang pumili ng pula, ito ang inyong gagawin. Gagawa kayo ng story ladder tungkol sa mga pagsubok ni Venus na ibinigay kay Psyche. Para naman sa pumili ng kulay luntian o berde, gagawa kayo ng character profile na tutukuyin ang kalakasan at kahinaan ni na Cupid at Psyche gamit ang graphic organizer. At sa pumili naman ng kulay asul, ito ang inyong gagawin. Magbigay ng 5 salita na maiuugnay sa mahalagang kaisipan sa kwentong Cupid at Psyche. Pagkatapos ninyong sagutin ang mga gawain, maaari ninyo itong ipasa sa nakatakdang petsa. Batay sa huling gawaing ibinigay sa inyo, ano kaya ang salitang nangingibabaw sa kwentong Cupid at Psyche? Magaling! Pagtitiwala. Ang salitang nangingibabaw sa kwento ay ang salitang pagtitiwala. Batay sa salitang pagtitiwala, magbigay ng 4 na salitang maiuugnay nito. Pakisulat ang inyong mga sagot sa module na ibinigay sa inyo. Sa puntong ito, magbibigay ako ng 2 tanong na nangangailangan ng inyong reaksyon at opinyon. Unang tanong, kung ikaw si Psyche, tatanggapin mo rin ba ang hamon ni Venus para sa pag-ibig? Bakit? Kung ako ang sasagot dyan, para sa akin, oo, tatanggapin ko ang hamon dahil naniniwala ako na ang wagas na pag-ibig ay hindi mo makakamtan pag hindi ka dumaan sa matinding pagsubok at suliranin at ang mga ito ay iyong nalampasan. Kalawang tanong, magbigay ng sariling reaksyon sa pahayag na hindi mabubuhay ang pag-ibig kung walang tiwala. Kung ako ang magbibigay ng aking reaksyon tungkol sa pahayag na hindi nabubuhay ang pag-ibig kung walang tiwala, sasang-ayon ako dito. Sapagkat hindi mo makakamtan ang wagas na pag-ibig kung ikaw o kayo mismo ay walang tiwala sa bawat isa. Ang pagtitiwala ang siyang pinakasentro ng pag-ibig. Kung isa sa inyo ay wala nito, hindi talaga magkakaroon ng mabuting relasyon. At walang relasyon ang mabubuo kung ito ay kulang sa pagtitiwala. Bago tayo magtapos sa pagkikitang ito, mayroon akong mga ilang pabaon para sa inyo. Ang pag-ibig ay hindi lamang basta emosyon na nararamdaman, kundi isang desisyon na dapat panindigan. Ang mata ay bulag, ang mga tenga ay bingi, kapag ang puso ang naghahari ng bawat tao sa daigdig. Laging tandaan, pwedeng kiligin, pero bawal mag-assume. At ulit, ito po ang inyong guro sa araw na ito, Ginoong Chester J. O. Iduria, na nagsasabing magandang araw sa ating lahat.